And the next one is input pin. So how can we configure the input pin? So we can configure the input pin in either floating or pull up or pull down mode. You see that. So there are three digital logic values when we talk about the logic values. One is logic high, another one is logic low, another one is floating, or we can also call this as a high impedance state or tri-state. So the floating value occurs when the pin is not pulled to logic high or logic low value level. So let us say this is one pin. We have some kind of pin, let us say like a PA5. So this pin is supposed to be logic low. It means logic low means logic 0, or it can be logic high. That is a digital world, right? So either it has to be logic low or logic high. So logic low is indicating 0 volt or 0.3 volt, let's say. And logic 1 is indicating if we set up plus 5 volt as the 5 volt tolerant, then plus 5 volt. But sometimes this pin is maybe somewhere in between this value. Maybe it's just like a 2.1 volt or 2.2 volt or some other values in between. So it's not coming to near to this 0 or it's not coming near to this 5 volt. So in this kind of floating situation will confuse the microcontroller. So in that kind of situation, we need to pull this pin to either logic 0 or to logic 1. So we need to either set up 0 or 1 instead of floating on the air. Okay, so the floating pin can be logic low or logic high or in between any value, or it will just keep changing the pin. Sometimes it will be logic 0, and immediately after a few seconds it will go to logic high, and then after a few seconds it will jump to somewhere in between value and then go here. So this is called like a floating. Okay, here question: if the pin floats in between any value, then how the microcontroller should identify? So either logic high or logic low, because all your components, all your devices inside the microcontroller is only considering 0 or 1, logic low or logic high. It doesn't know how should it interpret 2.5 volt. It's in between 0 and 1. It's in between 0 and 5 volt, right? So the microcontroller cannot really do anything. Microcontroller will get confused. Then you will get the wrong result and wrong function or malfunction. So how it happens? Because this floating situation happens if any. You may ask why this is happening to the pin. Why the pin is not going to 0 or plus 5 volt and why it's somewhere in between. So it's because of some external electrical noise signals. It happens in that pin that is making the pin to oscillate. So you know the oscillate. We know oscillation. What is the definition of oscillation? So whatever it just goes back and forth, then it's called oscillation. For example, if you have a swing in your home, you sit and then you just swing back and forth. That is oscillation. But in electrical engineering, we call of course, everything we are talking with respect to voltages and current. So here, this voltage level is just going back and forth. So between this 0 and 2.5 or this 5 and 2.5 volt. So it's just oscillating and it's not in any stable value. It's just a damped value. It's going back and forth. So it's happening because of the electrical noise in this pin. So even you remember oscillator, you have studied about oscillator, how oscillator is working. Any oscillator, we are not applying any input to the oscillator, if you remember. So we have the thermal noise inside this oscillator. This thermal noise will be developed, and then we have, of course, a feedback stage. This is a feedback stage. Any amplifier will have the feedback stage. and amplification stage. This is the amplification stage. And we take the output from the amplifier and take fraction of the output and then feeding to this feedback stage. And this feedback stage is given again input to this oscillator. So here we have the thermal noise. This thermal noise will be developed to a certain level. This is the gain of this amplifier A, and then the beta is the gain of the feedback stage. So this A and beta is called loop gain. This is a closed loop. And so the oscillation condition, Barkasian criterion. So that is the condition for oscillation. A Barkasian criterion. Barkasian criterion is telling us two conditions. The multiplication of these two gains, A, beta, must be equal to 1. And the input signal and the output signal, the phase difference should be 0. So angle of A beta must be 0 degree or 360 degree in order to get a stable oscillation. So at the output, you will get the oscillation like this, stable oscillation. In case if this A beta is less than 1 or greater than 1, then what will happen? The oscillation, either it will start from somewhere and then it will go little by little by little and then it will die, or the oscillation will start somewhere and then it will go more and more high. So but we do not want these two cases. We want the stable oscillation in the oscillator, because we use the oscillator in all the microprocessors and microcontrollers to generate the clock signals. Okay, this is called oscillator. The oscillator is producing oscillations because of the thermal noise. That is the concept of this oscillator, or working principle of this oscillator. The same is happening here in this microcontroller. In each pin in microcontroller, so in microcontroller have so many pins. Sometimes there may be some thermal noise or electrical noise happening in this pin. Because of this electrical noise, this pin is in the floating. It's not in a stable value. It's just moving back and forth between this 0 or any other value and then the high value. So in this kind of situations, we need to solve this problem. How to solve this problem? We must pull the pin to logic high or logic low by adding pull up or pull down resistor in that pin. So pin should be well defined. So that is how we can avoid this problem. You can eliminate this electrical noise by using pull up or pull down resistor. So we can avoid this floating and then we can bring this pin to either logic low or logic high. Okay, so pull up or pull down resistors are used when the GPIO pin is in input mode. Okay, pull up resistor is connected to VCC. Here you can see the pull up resistor. So, but pull down resistor is always connected to the ground. You can see pull down. So it's connected to the ground. So we have two different methods to do that. I will show you here in this slide. For example, when your IO pin is in open drain mode, so you know that what is this open drain mode? The pin can easily go to high impedance state. So because the upper PMOS is in the open mode. This is the PMOS and this is the NMOS. VDD. This is the ground. You are getting the output. And of course, you are applying the input here. So when you have this PMOS in the open mode, there is open drain mode, then this pin, this output is connected to somewhere in the input output pin, right? Some pin. So this is IO pin, GPIO pin, general purpose input output pin. So this pin can easily get into the high impedance state problem. So at the time we have to use this, we must use this pull up transistor to bring the pin to logic high. So here you can see we have the pull up resistor and we have the switch, and here we have the input pin. The switch, other end of the switch is connected to the ground. So, and this is the pull up resistor, and the pull down resistor is just we are exchanging the position. So we are putting the switch here, we are putting the switch in the top in the pull up chain, the pull down chain we put the transistor. Then this is called pull down sorry, we put the resistor in the pull down chain, so this is called pull down resistor. So either if you connect towards this VCC, then there is pull up, because you are bringing this pin towards to this VCC, pull up, or pull down. So you are bringing this pin to the ground value, pull down to logic 0. So these are the, is actually this is mainly needed, this pull up resistor and pull down resistor, when you use these microcontroller pins in I2C mode, inter circuit, integrated circuit, this I2C or I square C. So this is a communication interface, serial communication interface, serial communication interface. So mostly we know ESPI, or let us say just USB, universal serial port, right? USB, you know that you are always using this one in your computer. For example, if you want to transfer the picture from your phone to laptop, you are using some cable, USB cable to connect. So this is also serial communication cable. So this is just like it helps to make the communication between your PC or your laptop and some external devices. It can be either mobile phone or another pen drive or hard disk or whatever. So this is serial communication. This is the most commonly used one. This I2C, where do we use this I2C? So for example, you have the motherboard. In the motherboard, there are so many ICs. For example, you have the microprocessor or microcontroller, and you have the memories, and you have flash memory, SRAM, DRAM, and so on. And maybe you have some other external peripherals. For example, you have ADC or PWM IC, pulse width modulation IC. So these ICs should communicate between each other, right? So for that, we need to also connect them together in bidirectional mode. So at that time, we need to use this kind of I2C bus. So inter-integrated circuits. That is why this is called inter-integrated circuits. So to make the communication between the integrated circuits within the chip or within this PCB motherboard. So whenever we have this I2C, whenever we activate this I2C communication in the pins, this pin can go to the high impedance state problem. So at that time, we have to use this pull up resistor or pull down resistor to bring this pin to either logic low or logic high instead of floating. Okay, that is the purpose of this pull up and pull down resistors. You see here, this is the, if you go to the data sheet of any microcontroller, you will see this kind of diagram. So here, this is just for a single pin. The single pin, you can see we have the input driver, you have the output driver for this pin. So when you use this pin as an input pin, so of course this driver will be in active mode. You will be using this dotted part. So you can see here. So this here you can see here pull up resistor and pull down resistor. This is inside this input driver mode. For this is the diagram for F103 microcontroller, and this is the diagram for F407 microcontroller. So each microcontroller, the block diagram may be a little bit different. I will tell you the difference between these two diagrams here. For example, in F103, these pull up and pull down resistors are inside the input driver. That we know that it's inside this input driver, and this is the output driver. This is the input driver, this box. So these resistors can be used only when this GPIO pin is configured in input mode. So when you configure this pin in input mode, then only you can use this pull up and pull down resistors. You cannot, it means you cannot use when GPIO pin is configured in the output mode. If you configure this pin in output mode, it doesn't have these pull up and pull down resistors, but of course this has the push pull mode and open drain mode possibilities. So here you can see push pull mode and open drain mode. So that is possible when you set this pin as an output mode, but you cannot use this pull up or pull down resistors in F103. But in F107, you can see in this figure, we have the input driver and we have the output driver, right? And of course, here we have the pin. This is the pin. So you can configure this pin in the tool Cube MX or Cube IDE, either input or output mode. Regardless, you can set up this pin either as an input or output. You can use this pull up and pull down resistor. So this is an advanced version of the microcontroller. So in this advanced version, you can have this pull up and pull down resistors outside of these drivers. So you can use in either mode. Whenever whatever the mode you configure in this pin, you can utilize the function of these resistors. Okay, so that's all about this pull up and pull down resistors. Now we will go to this general GPIO input pull up mode. So this is the block diagram of GPIO pin. This is the GPIO pin. When it's configured in the input pull up mode. So you configure this as an input pull up mode. Okay, so what is happening now? So here you can see this is the internal diagram and then this is the pin, and I connect this pin to a button or switch, and the other end of the switch is connected to the ground. And of course I have this protection diodes. This is just a general purpose protection diode to avoid the reverse flow of the current. Okay, so when this button is pressed, what is happening? VDD is connected to IO pin. So when this switch is closed, this VDD is connected to this to this pull up resistor, and then it's coming down to this central node. Then what's happening? So IO pin is connected to the ground. It's active low. So here, because of this ground is of course pulling up here, and then it's reaching this IO pin, and this ground is going here to this schematic trigger, and then it's going to the input data register, and then the input control, and then the data is going inside the microcontroller. So here, let us say here the input data register value is 0. You know why? Because we bring this pin value to 0. So we are pulling up this pin to 0, and then this 0 is traveling here and then going to this schematic trigger. You see here, but in the other way, this is the VSS connected through this pull down resistor. So here we have also the same switch and the same pin. This pin is connected to this button or the switch, and the other end of the button is connected to the VDD. It's not the ground. In the previous one we had ground. So here in this pull down mode, we have this VDD. We are pulling down this VDD to this IO pin, and this logic 1 is traveling, and then it's just reaching this schematic trigger and then going to the input data register and so on. So you can bring either logic 0 or logic 1 to this input output pin, and this value is maintained by using these resistors. So otherwise, if you don't have these resistors, for example, VSS and VDD is not connected, then this pin can just get some reverse current problem, and it can go to the floating mode, and the pin will be in oscillation because of the electrical noise, reverse current due to electrical noise. Okay, so then you know this is the resistor, it's helping us in some way. And of course, here we keep this switch off. So this is not really, VDD is not conflicting with this VSS. So this pin is, you can set into logic high. So our problem is pin is floating. So we want to avoid the pin floating. We want to bring it to either logic high or logic low. So for that purpose, we are using these two resistors. So this is the block diagram when of the GPIO pin when it's configured in input floating mode. Okay, so when button is not pressed, then what is happening here? So here you can see this input output pin. It's connected to ground and also it's connected to the VDD. So it's connected to the VDD through this resistor and it's connected to the ground using this switch. And everything else is the same internal circuit schematic. So this pin is connected to this schematic trigger, and you have this pull up and pull down resistors. So now when the button is not pressed, then what's happening? This VDD is connected to this IO pin, then this VDD is traveling and then it's reaching this schematic trigger, and the output of the schematic trigger is 1. I hope it's not really confusing because we are seeing this in a different mode, because we are setting up this input in the pull up mode or pull down mode or in floating mode. Under each mode, how the pin is pulled up or pulled high. So that is what we are seeing in. So, okay, I think I do not want to confuse too much. So just try to have little information, but very clear information. So now we can see this. How can we configure the input GPIO pin? So first we are checking the system clock, and then we are checking the real-time clock, crystal clock, and then we are going to this configuration tab, and then you can check the pin, and you are setting up the pin. For example, you are setting up this pin for to input GPIO underscore input mode. And of course, you are setting up another pin as the LED. So when you set up this one, you can see here the label got changed, and you can see a small mark here, this kind of one. So that is indicating the LED red. You can also set up the label by yourself. And then you go to the clock configuration tab, and then you are setting up the clock. For example, this is a F103 microcontroller. So the maximum clock speed is 72 megahertz. So I am setting up this maximum value. And then you go to this main page again, and then you can go to this GPIO tab inside this, under the system. And in the IDE, maybe the user interface will be a little bit different. So here you can see, so we set up two pins. One pin, this PB6, we set up as the output push pull, and then we are setting up another pin as the input mode. Okay, so now we are in the output pin. So we can set up this output level. You want logic low or logic high, and then the mode you can select open output push pull or open drain. And the output speed, these are default, you can keep it. So here this PB6 is connected to the LED. So you can write the label, what label you want to have in the circuit, in the pin diagram. So this is for the output. This one we had seen open drain or push pull mode, and then this is the input mode. And the input mode you can also set up here. So you can set up, this is a pull up or pull down, or you don't want to have any pull up or pull down resistors. So you can decide. And the user label, you can set up whatever the user label you want. And then you can generate the code, C code. And then you go to the main.c, and then you can explore this. Okay, so I think that's all about this GPIO. So you can set up the input pin. You can set up the GPIO pin either in input mode or output mode. And then after that you can change the push pull or open drain or pull up or pull down.